Assalamu alaikum students. Today we solve exercise 3.5 and first question we solve linear equation with grammar rule. First of all we write it by matrix method. We name these matrices A, X and B. Determinant of A. We find its determinant. Expanded by row 1. 3 elements 2, 2 and 1 plus 2 minus 2 and 1. And then cross multiply each determinant. Next, to find value of x, we replace in column 1 the value of b. And then find its determinant and divide by the determinant of a. Next we find y. We replace value of b in column 2 and find its determinant by expanded by r1. 3 elements 2, 3, 1 plus 2 minus 3 and plus 1. We always arrange sign like first is plus, second is minus and third is plus. Value of 2 inside its determinant are except row 1 and column 1, and then value of 3 we eliminate r1 and r2, and for third element we have range r1 and c3, and for z we replace value of b in column 3. Now these are the values of x, y and z. Now in question number 2 we find a value of x, y, z by using matrices inverse method. First of all we arrange the equation. If any variable is missing we place it by 0, and then its matrix form EXB. X is equal to A inverse B. If A in left hand side in pre-multiply, then we multiply B with A inverse, pre-multiply by A inverse. First we find A determinant, then cofactor of matrix A. Cofactor are A11, A12, A13, A21, 22, 23, 31, 32 and 33. A11 we drop here first row and first column and the remaining value in the determinant 0, minus 1 and 2 minus 3. And with the 1, 2, A12 we drop first row and second column and the value is 2, 0, minus 1 and minus 3. And A13 we drop first row and third column, the value 2, 0 and 0, 2. Same we where find the values A21, 22, 23 and other 3, and then we place sign outside these determinants. We start with plus, minus, plus, minus, plus, minus, plus, minus and plus, and then transpose of whole determinant. First we find the cofactors, then we take transpose of the cofactors. It is equal to the adjoint of A. Now x is equal to A inverse B means adjoint of A over A determinant multiplied by B. we multiply these two matrices row into column because we have only one column and single values are in answer, and we divide it by the determinant which gives the values of x, y and z. Now in question number 3 we solve it by echelon method and reduce echelon method. First we write in augmented matrix. In augmented matrix, the coefficient and the value of b in same matrix, coefficient of x1 1 2 5, coefficient of x2 -2 3 -4, and coefficient of x3 -2 1 and -3, and coefficient and the values of b -1 1 and 1. And we first of all we want to make in column 1 2 and 5 equal to 0 in first column, second element 2 and we write r2 minus 2r1, and the third element 5 r3 minus 5r1. Now all values of r2 2 3 1 1 and values of r1 1 -2 -2 and -1. We multiply r1 by 2 and subtract r2 from these values, and these are the new values. Same in the second case, r3 minus 5r1. The new values are r1 r2 new values 0 7 5 and 3, and r3 new values 0 6 7 6. It makes first column equal to 1 0 0. Now in second column we want to make 7 equal to 1. Below 7 is a 6. We subtract it from r3 r2 minus r3, which make it 1. 7 minus 6, 5 minus 7 and 3 minus 6. Next we make the 6 equal to 0. 6 in which row? r3, and plus 6. Now we write there -6 and 1 in r2. Then we put these values and simplify. We make 6 equal to 0. Next in the C3 we have 19 and we divide it by 19. It makes it 1. For echelon method we make diagonal values and below diagonal values 0. Now we complete for echelon method, and then we write this matrix equal to quotients. x1 minus 2x2 minus 2x3 is equal to -1, and x2 minus 2x3 is equal to -3, and x3 is equal to 24 over 19. Because we have x3 24 over 19, we put in quotient 2 and get the value of x2, and then we put x2 and x3 in question number 1. And then we find the value of x1. Now to make reduce echelon from this matrix, reduce echelon method. Now we make upper values of diagonal equal to 0. To make -2 is equal to 0, we write r1 plus 2r2. Then we make -6 and -2 is equal to 0. r1 plus 6 r3 and r2 plus 2 r3. To make minus 6 is equal to 0, minus 6 in first row plus 6 r3 and r2 plus 2 r3 to make minus 2 equal to 0. Now the new values are there and we make the matrix A equal to identity, and on the right side we have the values of x1, x2 and x3. Now in question number 4 we solve the system of homogeneous equation. First we find a determinant which is equal to 0, and first solution of these equations are 0 0 0. If we put x0, y0, z0, it satisfies these equations. This solution is called trivial solution. Now others, to find other solution, we solve these equations simultaneously. Solve equation 1, 2 and then 1 and 3. From 1 and 2 we eliminate x. We make first equation 2x multiply 1 by 2 and then subtract. We get the new values. Y is equal to 3z, and when we solve 1 and 3 we make x is equal to 5x. We multiply first equation by 5, it makes y is equal to 3z. These equations are always same. Now to overcome this problem we let z is equal to t, a new variable. When we put z is equal to t, y is equal to 3t. We put z and y in equation 1 and we get the value of x. Now here in question number 5 we have a matrix form of the homogeneous equation. Here we have a value lambda. First we find determinant and find the value of lambda, and it gives two values of lambda, plus 2 and minus 2. First we write plus 2 and same method we solve equation 1 and 2 and then 1 and 3. In 1 and 2 we multiply first by 2 and then subtract these values. We get x2 minus x3, and then we solve 1 and 3. We multiply 1 by 3 and then subtract, and x2 is equal to minus x3. In the second case we have lambda minus 2. We place lambda by minus 2 and then solve these equations 1 and 2 and 1 and 3 to eliminate x1. Multiply a number to make the coefficient same and then subtract these values. We always, these two equations are equal. Here we have x2 is equal to 1 over 7 x3 and x2 is equal to 1 over 7 x3. Now in this case we let x3 is equal to t, then x2 is equal to minus t, and put in 1 x1, x2 and x3 to get the value of x1. In second case we put x3 is equal to t and then x2 and put these values in 1 to get the value of x1. Because we have two values of lambda, we solve for both. Question number 6 is same like this. First we find a determinant and find the value of lambda. We put value of lambda and then we solve question 1 and 2 and 1 and 3 simultaneously. We multiply question 1 by 2 when we solve 1 and 2 and multiply 1 by 3 when we solve 1 and 3. We subtract these values and we get the same questions. Next we put x3 is equal to t and x2 is equal to minus 1 minus 2t. Put these values in 1 and we have question x1 is equal to 6 plus 2t. Now this is exercise 3.5. Hope you understand. Try to solve each question in this exercise, and if you have any problem, underline your problem and send it to me. Thank you for watching. Jazakallah.